In the calm surroundings of the town of Versoix on the northern shores of Lake Geneva, the cosmic upheavals provoked by celestial bodies that consume their own matter are indeed millions of light-years away. And yet they are the daily subjects of investigation for Professor Thierry Courvoisier, the director of the Science Data Center for the European Space Agency's Integral mission. Since 2002, when it was launched by a Russian Proton rocket, the observatory has been exploring the gamma-ray sky, collecting radiation coming from the most energetic objects in the universe. These gamma rays are often emitted by very compact objects, things that are small but very dense. And these objects move very, very quickly. When they go very quickly, there are shocks, very strong heat is produced, and this heat emits light. So if one wants to understand the physics of these objects well, one is obliged to observe them in these gamma rays. Scientists using the Space Observatory target and study known objects, point sources of gamma rays. But the mission is also designed to record serendipity events, unexpected transient phenomena, as were observed on a day last May.
We try to understand what physically is happening in the system in which we think that there are two stars orbiting each other and one star is losing a lot of matter onto a very compact, very compact object, which might be a neutron star or black hole candidate or something like this.
In the ever-changing cosmos, Integral is thus playing the role of a sentinel, alerting the worldwide scientific community about new and unusual events in the high-energy universe.
We want to send as much information as we can to the owner of this data before we send this information out. So after this, then we will send an information email, and then after this we will send to the community an information about what's happening here, so that other observatories or telescopes can observe this source.
Over the past years, ESA's mission has regularly been making such chance observations. Several alert telegrams about unexpected phenomena are sent to the scientific community each month. An achievement all the more significant when one recalls that gamma radiation arises in all corners of the universe, and for meaningful observations to be made, Integral has to filter and discriminate between point sources and an enormous background noise. A dozen countries are involved and have contributed to the Integral mission. Amongst them, Poland's Centre for Space Research helped to develop the observatory's noise reduction system.
The satellite has a very noisy environment, noisy from the gamma point of view. So this is the system which led us to have the good scientific data on ground. So let's say this is one of the 3 or 4 the most important subsystems in the telescope. We have the detectors, we have the onboard computer, but we have also the noise reduction system, and this unit is the heart of this noise reduction system.
This highly efficient discriminating system at the heart of Integral observations has led ESA to entrust Polish scientists and engineers with another filtering system for the Herschel Infrared Space Observatory.
This is our, let's say, third project after Integral. It was Mars Express and Venus Express, and now Herschel is on the table, and we hope next year we will have the successful launch.
Polish astronomer Nicholas Kopernik would indeed be proud that in April this year, Poland became the 4th ESA European cooperating state, alongside Hungary, the Czech Republic and Romania. But back to Switzerland and the Integral Science Data Center, with another fundamental question: why study this violent gamma-ray universe? What we're contributing to society with Integral doesn't lie in immediate practical applications. It is a knowledge of the world around us, this cultural aspect, the subjective view of the world which we are changing little by little, modestly. But it has a profound impact on the course of things, and I believe a positive effect on society.